Hello, welcome again. So in this part, we will solve the problem set 2 from the chapter 10. So here we have only two problems. So in the first problem, we will calculate the asset retirement obligation, and in the second problem, we will calculate the accretion expense for 3 years. So let's go. So the first one, Montana Mining Corporation, MMC, paid $200 million for the right to explore and extract rare metals from land owned by the state of Montana. So to obtain the rights, MMC agreed to restore the land to a suitable condition for other uses after its exploration and extraction activities. MMC incurred exploration and development costs of $60 million on the project. So the MMC has a credit-adjusted risk-free interest rate that is 7%. It estimates the possible cash flows for restoring the land. So the 3 years after its extraction activities begin. So the cash flow probability, say the 10 million probability is 60% and the 30 million probability is 40%. So what is the amount of asset retirement obligation that should be recognized by MMC at the beginning of the extraction activities? So let's do it. It should not be difficult, okay. So the first thing we need to do, we need to calculate the present value. First, we need to calculate the expected value of the cash flow, okay. So expected cash flow, in that case, let's see. So the expected cash outflow. So total 10 million and the probability is 60%, okay. So it's equal to 10%, I mean 60% of the 10 million. Let's make it smaller. So that is equal to 6 million, correct? And 30 million, so the probability is 40%. So it's gonna be 12 million, okay? So the total expected value. So the total expected value is 18 million, okay? Expected cash outflow. Okay, and now present value factors. We know that I equal to 7%, okay, and n equal to 3. So therefore the present value factor from table would be equal to, and let's see, so the I equal to 3 and it is 7%, so it's gonna be here 0.816 we can find. So 0.816, okay, 3, okay, and now the present value would be equal to 18 million multiplied by 0.8163, which is equal to 14,693,400, and which is equivalent to 14.7 million, okay. You got it? So where is the answer? Okay. We calculated that. So the total asset retirement obligation. So asset retirement obligation is 14.7 million. Okay, and now come to the second one. So this one is a long one. So on March 1, 2018, the Shipley Resources entered into an agreement with the state of Alaska to obtain the rights to operate a mineral mine for $6 million. The mine is expected to produce 100,000 tons of mineral. As part of the agreement, Shipley agrees to restore the land to its original condition after mining operations are completed in approximately 5 years. Okay, so we need this one. So the management has provided the following possible outflows for the restoration costs that will occur 5 years from now. Okay, so the 300,000 possibility is 25%, 400,000 possibility 50%, 500,000 possibility 25%. Their credit adjusted risk-free interest rate is 10%, and during the 2018, so the company extracted 18,000 tons of ore from the mine. So how much accretion expenses will be recorded in the company's income statement for the year 2018, 19 and 20? Okay, so the first thing we need to do is to calculate the expected, let me copy this one, it will be better. So expected cash flow, cash outflow. Okay, so the expected cash outflow, I am just deleting this one. So the expected cash outflow would be, the first one is 300,000, and then the probability is, what is the probability? 25%. Okay, and the total value is gonna be 75,000, and then 400,000, the probability is 50%, so it's gonna be equal to 200,000, and finally 500,000, the probability is 25%, which is equal to 125,000, and the total is gonna be 400,000. Okay, so the total expected cash flow, so the total expected cash outflow is 400,000. Okay, so now close this one. Okay, and now present value factor. Okay, sorry, present value factor. So to calculate the present value factor, the I is 10%. Okay, and n equal to 5. So the present value factor is equal to, so the present value factor from the table. Okay, present value factor from the table would be equal to, and let's see, so the n is 5 and the interest rate is 10%, so the 0.621. okay, so 0.621, and it's gonna be 0.621. okay, so the present value of expected cash outflow is equal to 400,000 multiplied by 0.621, which is equal to 248,000 368. Okay, now this is the asset retirement obligation is 248,368. Okay, and now accretion expense. The accretion expense for 2018. So 2018 accretion expense. See, when we are calculating the accretion expense, we need to be careful about when we have started the project. So on March 1, 2018. So let me just insert 12. Okay. So this one is January, February, March, April, May, June, July, August, September, October, November, December. So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. Okay, out of 12 months we have started from here. We started the project from here. So what I'm gonna do, design. Okay, shade. Let's put a shading over here. Okay. So how many months? 10 months, correct? So total 10 months in 2018. Okay, and now so the accretion expense would be equal to 248,368 multiplied by 10% multiplied by 10 over 12, because 10 months. Okay, out of 12 months, 10 months. So which is equal to 20,697. Okay, and the journal to record accretion expense would be equal to accretion expense debit 20,697 and asset retirement liability 20,697. Okay, and in 2019 the accretion expense would be equal to, see, 248,368 plus 20,697 multiplied by 10%. This is for the entire year, so that is why we don't need to multiply it by 10 over 12. So this is the total for the total year, correct? So, and the amount is gonna be 26,906.5, and for 2020 the accretion expense, so the accretion expense is gonna be total, so it's gonna be total 248,368 plus 697, sorry, 20,697 plus 26,906.5, so, and multiplied by 10%, and it's gonna be total, so 29,597.15. So this is how you solve the problem. Okay, and let me know if you have any question. And for the journal entries, you will record the same journal entry for every year after calculating the accretion expense. Okay, so this one, so this journal entry. Okay, have a good one.